Hello everyone. On this video I wanted to talk a little bit about some handouts. So the first one is just the Chapter 7 handout, which you can find on Blackboard under the handout section. And a couple things to notice here. So in Chapter 7 we study 7.1, 7.2, and 7.3, and they all deal with confidence intervals. So when we're talking about population mean mu, that's going to be either section 7.1 or 7.2, and they both use this. The only difference is when we're in section 7.1, right here is when we know sigma. So this right here, this is section 7.1, and that is when sigma is known, which we mentioned in the 7.1 video. It's not very often that that's the case in practice, but it's the easier one to understand, so it's typically studied first. Now, what is more often the case in practice is when sigma is unknown. So, because remember what we're trying to do, we are trying to build a confidence interval around the population mean. So typically, if we don't know the population mean, we also wouldn't know the population standard deviation. So in section 7.2, which is this case, so section 7.2 is here, section 7.1 is here, and in section 7.2, we're going to use t-scores, or students t, and we use little s. We're going to use the sample standard deviation, and we use those to find our maximal margin of error. But it's very similar to 7.1, but in 7.1 we use a z-score, and we use sigma because it's known. So for section 7.1 and 7.2, we are building confidence intervals for the population mean, right? Population mean. So it's 7.1 and 7.2. The only difference between these two sections is in 7.2, they're going to say we don't know sigma. So then we use students t instead of the standard normal. So we have the standard normal here in 7.1 with z-scores. In 7.2, we use students t with t-scores. And then in 7.3, well, we switch from the population mean, mu, to the population proportion, p. So this is section 7.3. You can see they're all really just dealing with the same thing with confidence intervals. But now we use a confidence interval for proportions. And it looks very similar. We use this one for both 7.1 and 7.2. Remember, there's just different ways to find E. And then we have something very similar here where we're trying to estimate not mu, but P, the population proportion. So we use P hat here. And we've got our error formula, and we're back to z-scores. So one thing that I always say to my students too is whenever you're dealing with population proportion, we always use standard, normal, and z-scores. We only use students t for section 7.2 when we're trying to find the population mean and we don't know sigma. When we're dealing with population proportions, we're back to z-scores. We're back to the standard normal distribution. And so we've got a formula here for E, which we'll go over in section 7.3, but it's very similar. Chapter 7 is all dealing with one thing. So we also sometimes need to know about the minimal sample size. So down here, we just have to know what we're trying to estimate. Are we estimating means? If we're estimating means, then we use this formula, right? Estimating means. This will be in section 7.1. Or if we're trying to estimate proportions, well, then we use these two formulas depending on the situation, but these are both from 7.3. So we just have to know what it is we're looking for. Are we looking for the sample size for estimating means or the sample size for estimating proportions. And then there's two different formulas here, and we'll talk about which one to use in section 7.3. So that's the Chapter 7 handout. Make sure when you're working on Chapter 7 problems that you have that available. There's another handout that I often just give to students when we're in class as a little extra material, just for you to read to get another viewpoint of a confidence interval. And this is one that I put on, it's on Blackboard under our lecture notes as a 7.1 addendum. It's just this one page, and when you get a chance, you probably should take a look at it, especially if you're new to confidence intervals, because they're a little bit tricky, and this just kind of explains confidence intervals, and sometimes just seeing it explained or hearing it explained a different way, or just hearing it explained again, kind of fills in any gaps that you may have. So it really is a good one, and when you get a chance, just take a look at it. And there's one more handout that is under the lecture notes as a 7.1 addendum that we should take a look at, that I would typically pass around in class during the lecture. And this one is a confidence interval dealing with probabilities. And just like in class, when these population projections come out, they're not given as a number, but as a range of numbers. So you can see right here we've got the dark tint is an 80% probability range, which would be like an 80% confidence interval. And then you've got a 95% probability range, which would be like our 95% confidence interval. So it's just another example of some of the things that you'll see, when you get out of statistics, and you'll probably notice these things that you maybe didn't notice before. And it's closely related to what we're doing in Chapter 7. And then there's one more that I'll mention. Just have to move this over a little bit here, and we'll talk about a different one. And this one, something called a landing ellipse. And this has to do with computer models that are used to predict potential areas of impact for landing spacecraft. So, in other words, we had, let's say in 1976. 1976, we had the Mars Viking lander. And there's a landing ellipse, which is very much like a confidence interval. So we'll have this region here, and this would be 80%. So we could say something like we're 80% confident or 80% sure that this landing craft will be somewhere in this region. And then if we want to be more confident, we have a larger region. And now we could say we're 95% confident that the Mars Viking lander will land somewhere in this region. So just like before, what we noticed was we're more confident, but the trade-off is a larger region. So in 1976, computer models, as you can imagine, were pretty crude, and we didn't have a lot of data. Even if the models were good, we didn't have much data about the atmosphere of Mars. So in 1976, this 95% confidence interval was 62 by 174 miles, which is nearly the size of New Jersey. So as you can imagine, as we learn more and have better computer models, and some of the things we even learned from this Mars Viking project led to, let's say, 2012, much more modern, right? We had the Curiosity lander, and now we have better information. We know more about the atmosphere, We're better able to predict entry angles. We have better computer simulations and better computers, much more powerful. So we still have a landing ellipse, but it's much smaller. So now it's no longer 62 by 174 miles. This one in 2012 was 4 by 12 miles, which is about 200 times smaller. And as you can imagine, as we get better and better, get better computer models, get better data, these will get smaller and smaller. So it's just a couple examples that just come to mind, and you'll see others in class and probably see others after you get out of class also.